Okay. All right. So tell me, what are the supplies that you all have? See, for the first experiment, we'll need a candle. Okay. Matchbox, pencil and eraser, polythene, and paper. Okay. All right. So what you'll have to do, see all of y'all, Shira, put your video on. Nishaya, you also put your video on. Are you all ready with these supplies? You'll need a polythene, okay, a piece of paper, candle, matchbox, pencil, and an eraser. See, you'll take a small part of the eraser, okay? A very small part of the eraser. Instead of pencil, what you can do, the matchstick now, the back portion of the matchstick also you all can take. Yeah. All right. So what we'll do, first of all, we'll burn the candle. Now, the aim of this experiment is to find out what is the ignition temperature of these things. Now, what is ignition temperature? It is the lowest temperature at which something catches fire. Okay. So, y'all are going to note down which substance is taking a longer time to catch fire and which substance is taking a lesser time to catch fire. Okay, so ignition temperature is the lowest temperature at which something catches fire. So in this experiment, we are going to find out what is the ignition temperature. We cannot exactly find out what is the ignition temperature, but we can find out which substance catches fire easily and which substance takes a longer time to catch fire. Okay, so light up your candle. See, first I'm demonstrating. You all see how it's done. Then you all will see it for yourselves. Okay? And you all will tell me what is taking a longer time and what is taking lesser time to catch fire. I think what we can do is, are you all having a stopwatch with you all? See, we can also find out the ignition temperature by looking by taking into account what time, like how many seconds it is taking to catch fire. Okay. So now I'll be doing this. Do you have your phone or something beside you all?
Nicola ma'am, I can do the stopwatch. I can do it for you.
Okay. Okay, fine. All right. So first I'll be burning paper. Okay. Y'all can also, then if ma'am is doing the stopwatch thing, then y'all can also do it together with me. Okay. And when y'all finish, then y'all can tell ma'am. See, all of us can do it with paper. We can all record it.
Okay, so I will tell you when to start. Okay.
Yeah.
So, because we'll be having little bit of lag, so a few seconds here and there will happen for all of
everyone.
us. Yeah. Shira, can we have your video on, please?
Are you all ready with the paper? use a tongs. Okay, use a pair of tongs for to hold the things to burn it. Ready, everyone?
Just a second, ma'am. Just a second.
Okay, fine.
All of y'all grab a piece of, grab a pair of tongs, okay?
Yeah, you'll have to use a pair of tongs.
We'll wait for Janvi.
Yeah.
Janvi, are you ready? Janvi, can we have you? All right, are the others ready?
Yeah, I think we can. Janvi can join from the next item.
Yeah. All right.
Yeah.
So I'll do a countdown, and on the count of one, you can start, or on the count of three, you can start burning. Okay. 1, 2, and 3.
Stop.
Okay. So who said stop? Nicola, ma'am, you?
Yeah.
See, it took 3 seconds for paper.
Okay.
Okay.
Did yours paper start burning quickly, or did it take a long time?
Mom, it started burning quickly.
Mom,
Yeah. Yeah.
Okay.
Okay.
So
So it
in
will
your
be.
books you can write, or in the in just make a note that for burning paper it took 3 seconds. Come on, Janvi, try it out.
Yeah.
3, 2, 1, go. Okay, so for Janvi it just took like 2 seconds approximately. So Janvi,
Okay.
write down 2 seconds. Janvi, put it off. All right. So which is the next object that we are trying?
We are going to try with polythene.
Okay. Have a piece of polythene. Take smaller pieces so you don't end up, damaging any objects which are close by. Take smaller strips of whatever you are taking, because too much of paper will or plastic anything will cause a lot of damage. Keep a scissor handy. Take a small strip.
Okay. Is everyone ready with the polythene? Okay. Everyone is ready, right?
Okay.
Okay.
So on the count of three. All right. 1, 2, 3.
Stop.
So about 3.75 seconds.
Ma'am, it was melting, then a blue flame occurred.
Yeah. So basically, it starts melting at a lower temperature, but it catches fire later. Okay. So 3.75 seconds for plastic.
You all take a matchstick. Okay.
Take a matchstick, but burn it from the other side, like
Other end.
the wooden part.
Yeah.
Can I do it with the pencil?
Um,
Yeah, you can do it, but like it will take a longer time for pencil. Means we just want to see what time would take. So this is the best thing. Don't you have matches, Nishraya?
No. No, ma'am.
Okay,
you
then you
have
can try it.
you can try, but it'll take a longer time.
Okay.
No worries. Okay. All right. On the count of three again. 1, 2, and 3.
Stop.
Did it start at the same time for all of y'all?
Yes, ma'am.
For Janvi, it happened early. Okay, so as per Nicola ma'am's, it took 5 seconds.
Okay.
Okay, so Janvi, yours was a second before that or a few seconds before that?
2 seconds before that.
Okay, so you can write it.
Ma'am, the pencil burned at about 8 seconds.
8 seconds, okay.
So you can take a note of that.
All right, which is the next object that we are doing?
Eraser. But you all can take a small part of it, okay? A small part of the eraser you all can take.
All right, ready?
Yeah. Wait.
Okay.
1 second. Yeah.
Okay, again on the count of three. 1, 2, and 3.
Stop.
Ma'am, mine
Okay.
burned at the count, like in 2 seconds.
Yeah, I know. I saw that. I saw that. And Nicola ma'am's, it took about 4.5 seconds. Come on, Janvi. On the count of three. 1, 2, and 3. Okay, almost 20 seconds, Janvi. Because it was a bigger piece of rubber. All right. Which is the next object that we are testing?
That's it.
Okay.
These are the four. Yeah.
Okay. All right.
All right. So tell me, look at your observation and tell me which has lower ignition temperature.
Eraser.
Which object? Okay. For you, the eraser had lowest ignition temperature, right? What was your temperature? Like what was the time that it took to burn?
2 seconds.
2 seconds. All
Mine
right.
was
Shriram, for you?
plastic.
Okay. Plastic. What was the time? What was the time that it took to burn?
Ma'am, 2 seconds.
2 seconds. Okay. For you, Janvi?
Paper. It took 1 second.
One. All right. For me, also paper had the lowest ignition temperature. Okay. So the concept of ignition temperature tells us that like what is the lowest temperature at which a substance starts burning. Okay. So that is the ignition temperature. Okay. Did you all understand this activity? Okay. We'll move on to the next activity now. So, ma'am, can you show what is the next activity?
Yeah, the next activity is heating of water in the paper cup.
All right. Yeah. So you'll need paper, candle, and water. Okay. You'll have to make a paper cup like this. Can you all see? Okay. See, make sure that at the end, like there's no gap for the paper, for the water to like leak out.
Nishchaya, you can use that, but when you're heating it, heat from the center. No, because there is a small, there's a small extended paper in the corner. So heat at the center.
Okay. So those who don't have these paper cups, like I also have these paper cups. Those who don't have them, you all can make this kind of a paper cup also. So Janvi has made them, right? Shira, do you have paper cups? Okay. You need two. Shriram, you need two.
Excuse me, ma'am, how many paper cups do we need?
We need two paper cups.
Paper cups, okay.
Can you please keep your videos on?
Materials?
Uh, your name is Devraj, right?
Yes, ma'am.
Can you please keep your video on so we can observe what you're doing?
Okay.
Yeah, and Sakshi, you also please keep your video on.
Okay. So, have you all collected the supplies?
Yes, ma'am.
Okay. So, first of all, we'll record what time it takes for the paper cup. See, there will be two paper cups. One paper cup, you all don't have to add water. And in the other paper cup, add about 100 ml of water. One paper cup, no water will be added. In the other paper cup, add about 100 ml of water to it. So I'll tell you all approximately how much, because Most of y'all are having these paper cups, right? See, y'all can fill the paper cup with water.
And full cup.
Yeah. Okay. Don't let it like overflow, but almost full. All right. Janvi, you can just fill your this paper cup like this. Okay. Just put little bit water in one. Okay. First, what we'll do, you'll have to light the candle.
See, listen, children. Fill only that much water in the paper cup, which you will be able to lift easily with the tongs. Okay? Otherwise, you'll end up spilling the water on your tables. Okay? Even if you fill it to about 1/4 of that cup, that should be more than enough.
Okay. The first paper cup, you'll have to record the time, what time it takes
So you'll keep your stopwatches
to
ready.
burn it.
Okay, and measure the time taken for the first paper cup to catch fire. That is the empty paper cup. All right, you all have your own stopwatches, right? Available with you? Come on, start it. Nicola ma'am, I'll do it for you.
Yeah.
All right, so on the count of 3 again. 1, 2, 3.
Stop.
Okay, so it
6 seconds.
about 12.5 seconds it took for Nicola ma'am's cup to catch fire. Janvi's would have caught fire very fast.
And my mine 6.35 seconds.
Mine also,
Okay,
ma'am,
Jan
got fire very fast.
Mine took 20 seconds to catch fire.
Oh, it took 20 seconds. Okay. You made it from a drawing sheet or something?
No, it's just normal paper. I think
Oh,
it's tracing paper or something.
okay. All right. All right. So next will be when we,
Yeah, the paper cup with water.
yeah, paper cup with water. So fill only 1/4 of the cup with water and be very careful while you're handling it. Okay. Now again, you'll have to record the time. So on the count of 3, 1, 2, and 3. Nishreya, we tried with the empty paper cup. Now we are doing with the paper cup with water.
My mine was 10.29 seconds.
How much?
10.29 seconds.
Your paper cup got, it got fire. It caught fire.
Yes.
What kind of paper cup do you have, Devraj?
It's a normal cup.
Where did it catch fire? Did it catch fire at the corner or did it catch fire at the center?
It catch fire in the corner.
It won't, that won't count because the corner is an empty piece of paper. Like while we started the experiment, I told you all that you'll have to burn it from the center where there is water. Okay, so that time won't be counted. You can start it again, Devraj.
Okay, ma'am.
What
Are you
happens,
noticing that
Sriram?
it takes a longer time for the paper cup with water to like catch fire?
Yes, ma'am.
Yeah.
Why is it taking longer time?
Ma'am, because due to the water, the ignition temperature cannot be reached as early as with the paper with the cup which do not have water.
So
Yeah.
when do you think this paper cup will catch fire?
When the ignition temperature can be reached.
Okay. So that means the water also has to be heated up till that temperature. So that,
Yes, ma'am.
yeah, so that an equilibrium
Ma'am,
can be achieved. Yes.
ma'am, when the water will be evaporated from the cup, then it will catch fire, I guess.
No, even the water has to reach the ignition point. Not all the water will evaporate from the cup. Okay, it will take a very long time for all the water to evaporate.
If
Yes, ma'am.
you keep it for longer time, you'll see the water will start boiling. Okay.
So theoretically, we say that if there is water in a paper cup, that paper cup won't catch fire.
Yeah.
That means
It
it
won't catch.
doesn't catch as early as the empty paper cup.
Yeah.
Ma'am,
Okay.
the water is hot right now. The water is hot.
The water is hot.
Yes.
Has the paper started lighting up?
Not yet.
Not yet.
It's,
Okay.
it's just black.
Yeah, that's due to the
Yes.
due to the fire. All right. Okay. So this the like to burn this paper cup with this water, it will take a lot of time. See, we have already crossed about 3.5 minutes. Okay, and the timer is still ticking. All right. So we understand from this that the ignition temperature of the paper will vary when it contains water in it. All right.
Okay. So,
Mm,
what's the next activity, ma'am?
yeah, give me a minute.
Is it fire extinguisher?
No, next is
Yeah.
the candle and then the fire extinguisher.
Okay. All right. So all of y'all heat the light the candle. Sorry. And observe the paths of the flame. Y'all will all tell me what are the parts of the how many parts the flame is divided into. Like what are the different parts of the flame that y'all can observe? Who's going to start?
Yeah, so we will go to each one of them. We'll start with Shriram. Come
Yes,
on,
ma'am.
tell us how many parts does the flame have? You can see the flame and
Ma'am,
tell us.
ma'am, the first zone is the non-luminous zone, which is the hottest part. The second is the luminous zone, which is
You're going
mildly
from
hot,
inside to outside or outside to inside?
outside to inside.
Okay.
So outside, the first layer from outside is the non-luminous zone. It is the hottest part of the flame. Then in the middle, there is the luminous zone, which is moderately hot, and at the bottom is the dark zone, which is not hot.
Okay, so you can please So you can see three zones, right?
Yes, ma'am.
Okay. Now we move on to Sakshi. Can you tell us?
Mom, I'm still lighting my candle. The wick is too small.
Okay, we'll come to you. Devraj, can you tell us?
Yes, ma'am.
All of y'all put your cameras on, please.
Yes, ma'am.
All of y'all turn your videos on.
Yes. Yes, ma'am.
Okay, can you tell us like how many zones the candle is having?
It has three zones.
It has three zones. So what is the difference in the zones that you observe?
So, ma'am, I'm telling from inside to outside.
Okay, fine.
So, ma'am, the inside zone is not so much hot. It's the black part. It's black in color,
Okay,
and it is not so much hot.
all right. Then,
The second zone, which is uh, which is a slightly blue color,
okay,
means
yeah.
it,
And the third one?
and the third one, which is very hot, the last part, means the yellow part, it is very hot, and the third zone.
Okay, all right. Okay. Janvi, can you tell us what are the three zone, like what are the zones that you observe?
There are three zones.
Okay,
So I'm saying from outside to the middle to the
okay,
bottom.
yeah,
Yes, the outside is the hottest part, which is
okay.
zone.
Janvi, you're mute. Janvi, you're on mute.
Oh, okay. So can you hear me?
Yeah, we
Yeah.
can.
So out.
Who is Amit Patil?
Amit Patil.
Um, Someone muted.
Yeah, Amit Patil. Who's Amit Patil?
They left the meeting.
Okay, you can continue, Janvi.
So the outside part is the hottest part. The outer zone is the hottest part, which is the completely combustible zone, and
Yeah.
the middle part, which is moderately hot, which is partially combustible, and then the least hot part, which is I don't remember.
Okay. Which is the innermost one? Okay,
Innermost
fine.
one.
Yeah. Who else will say now?
Ma'am,
Nishreya,
may I
let's
tell?
go to
Sakshi, are you
Nishreya.
ready? Sakshi, are you ready?
Yes.
Okay. Can you tell us what are
So
the zones that you observe?
my wick is small. So I can see like only like a blue layer and an orange layer on top.
Okay. Nishraya?
Nishreya, I want you to tell me all the three layers with their colors, okay?
First layer in like the innermost layer, it's blue, and the second layer it's orangish, like it's a little faded kind of a thing, and the
Okay.
topmost one is very bright. It's yellow and orange, like mixed, really bright.
Okay. All right. All right. Who else wants
Ma'am,
to
may I
say?
please tell?
Yes. Say.
Okay. So the
The innermost part contains
One
unburnt.
second, Varat, please turn your video on so we can see your candle.
Actually, ma'am, I don't have my candle with me.
Okay, so
Should I
all right.
continue?
Yeah, please.
Yeah.
Okay. At the innermost zone contains unburnt carbon particles, and it is the least hot part of the flame. And the middlemost zone is the brightest zone of the candle, and it is moderately hot. And the outermost zone is the non-luminous zone, and it is the hottest part of the flame. Also, the part which is blue in color is the hottest part of the flame. So we can consider that Bunsen burner is one of the most hot flame we can consider.
Okay. All right. Okay. So yes, the candle has three zones. Okay, the innermost zone that that contains the unburnt carbon particles. Okay, then you see the yellowish zone that is you can say the luminous part of the candle. Okay, and the outermost one, which is the most hottest zone. The middle one is moderately hot. Okay, and the outermost zone, that is the hottest of all. Okay, but it is non-luminous. So these are the three zones of the candle. All right. So we'll move on to the next activity now. You'll need a glass container, a candle. You'll need baking soda and vinegar for the experiment. You'll also need the matchbox with the matchsticks, of course. Okay. So these are the things that you'll
Ma'am, I
require.
don't have a glass container. Can a paper cup be okay?
Yeah, okay, fine. But you have to, hold it in a tilted manner. So you have to be very careful that time. Okay.
Okay, ma'am.
Yeah. So what you need to do is you'll need to add vinegar to your container. Okay. And you can add about 5 tablespoons of vinegar. Just give me a second. So you'll need to add 5 tablespoons of vinegar. Have you all done it?
Yes, ma'am.
Sorry.
Hello, ma'am.
All of y'all have done it? You all have added
Ma'am,
5 tablespoons of vinegar.
ma'am,
Yes,
this.
ma'am.
Who's Virat? Nicola, ma'am, you're on mute.
Okay, fine. Now you all can light your candle. Okay. Now what you all can do, you all have to add 1 tablespoon of baking soda. Okay. And you'll have to tilt your container like this. Is like Is the setup visible? Like what you'll have to do? You'll have to add 1 tablespoon of baking soda and you'll have to tilt your container like this. Is that clear to everyone? Is it clear? Like what you'll have to do?
Yes, ma'am.
Okay. So that is what you'll have to do. Okay. Add 1 tablespoon of baking soda to y'all's vinegar and then immediately tilt y'all's container.
See, the
Don't.
reaction happens
There'll be
very
a
fast, okay? Reaction happens very
yeah.
fast, so you'll have to be really quick. Immediately, as soon as you add the baking soda, you have to tilt it so that the gas which comes out of it reaches the flame.
Yeah.
See,
Have you
did you
seen?
all observe Nicola ma'am's experiment?
Yes.
Okay.
Ma'am, I didn't understand.
Alternatively, what other students can do is if they have a smaller piece of candle and if the length of the candle is smaller than their glass, they can empty out the glass, put the candle inside the glass, pour vinegar, light up the candle, and then add baking soda to the vinegar. So put your candle inside the glass. Let it stand inside the glass.
So, ma'am, we have to keep, if our candle is smaller, then do we have to keep the candle inside the glass?
Um, Someone called Virat Gane, he muted Janvi.
Okay, Janvi. What?
Okay,
Um,
Who's Virat?
I don't know. All right. So Janvi, I was saying that take a smaller candle, put it in the glass.
my
Now,
candle fits inside the glass.
okay. So around the glass, add little bit of vinegar, and then light up the candle, and then add a spoon of baking soda.
Okay.
Okay. The flame of the candle should be inside the glass. If it is coming outside the glass, then I'm not sure whether the experiment will work. Okay. Turn the flame off before putting it in. Will you be able to do it? Because, yeah. Shriram, are you able to do it?
Ma'am, I'm doing it.
Yes. Sakshi?
Yes, ma'am.
Nishya, that is also a good way to do it.
Ma'am, it extinguished, ma'am.
It extinguished, right?
Ma'am, I think it is due to that gas.
Yes, it is due to the gas.
Yes. What is the gas that is being produced? Does anyone have any idea what is
I
the
think
gas?
it is hydrogen.
No.
Ma'am, carbon dioxide.
No. Yes, it is
Uh,
carbon
you
dioxide.
have to add a little more baking soda and vinegar, Janvi. What happened to Nishya? Nishya, what is happening?
Now I'm trying again. Just a minute.
Yeah. Take fresh vinegar, okay? Once, if your reaction is completed, no, the same vinegar won't work. Sakshi, are you doing it?
Yes, ma'am, it worked for
Okay,
me.
very good. Take little bit more baking soda, Janvi. Oh yes, Nishreya, finally it went off.
Yes, ma'am.
Very good, Janvi.
So the gas that is being produced is carbon dioxide gas. Okay, carbon dioxide gas is used in the fire extinguishers. Have you seen fire extinguishers? Okay,
Yes.
so it is used to cut off the supply of oxygen. Okay, it is used to cut off the, because oxygen is required for combustion. So what does the carbon dioxide do? It cuts off the supply of oxygen. It cuts off the connection between the candle that is burning and the oxygen. Okay, that's how the candle goes off. Did you all understand this activity, all of you?
Yes, ma'am.
Yes.
Okay, so we move on to the presentation now. All right. So in the last class, we discussed about combustion. Can anyone tell me what do you mean by combustion?
Ma'am, burning of a substance to produce carbon dioxide is known as combustion.
Okay. So the burning of something is known as combustion. Okay. And what are the things, what are the factors that are required for combustion? Who will tell me? What are the factors that are required for combustion? Yes, Jackie.
Oxygen, fuel,
Yes.
oxygen, sorry, oxygen,
Yes,
Ma'am,
fuel,
ignition
oxygen.
temperature.
heat, heat, oxygen, fuel, and heat.
Yes. So these are the three basic things. These are the three important things that are required for combustion to happen. If any one of these things are missing, then combustion will not take place. Okay? All right. Can you all tell me what is a fuel? What is a fuel? Who's going to tell me what is a fuel? Yes?
Ma'am,
Ma'am, Virat, muting you, ma'am.
Who is Virat? Okay, Nishaya, you say.
um, I just forgot. Swapna, can you please take out him from the meeting so he won't be able to join again, hopefully.
Nishaya, can you tell me, like, what is a fuel?
Ma'am, fuel is a substance which is used to, which burns. It catches fire.
Okay. It catches fire. Okay. All right. Now, on the basis of combustion, we learned about two types of substances. Okay. On the basis of combustion, we learned about two types of substances. What are those two types of substances? Tell me. Yes, Nishaya.
Combustible and non-combustible.
Okay. So combustible and non-combustible. Examples, who's going to tell me?
Ma'am, Virat Khatne is muting everyone.
Sita ma'am, can you please take care of this? Sita ma'am. Okay, Nicola ma'am, you can continue. I'm sorry, we'll
Yes.
take care.
Hello, yes, ma'am. Virat Khatni is not from my school. You can remove him.
Okay. All right.
Okay, Janvi. Yes, can you tell, can you give examples of combustible and non-combustible substances?
A combustible substance could be wood, paper, and
Okay.
non-combustible substances could be metals,
Okay.
like gold. It's not
Okay,
combustible.
fine. All right. So now we can proceed with the presentation today. Okay. We can move on to the next slide. Okay. So we already learned about what is a fuel. Now we are going to learn what are the characteristics of a good fuel. Like what are the things that are required? What are the properties that should be present for us to term a fuel as a good fuel? First and foremost thing, that it should be easily available. If it is not available, anyone cannot get access to it, and then we cannot term it as a good fuel. Okay, so it should be easily available, and it should be affordable in price, so that everyone can purchase it. Okay, everyone can make use of it. Then it will be, and then it can be considered as a good fuel. Otherwise, if it is not affordable, if it is very costly, then it cannot be considered as a good fuel. The next thing is that it should produce large amount of heat. Okay, when a fuel produces large amount of heat, then only it can be considered as a good fuel. If it produces a very
Ma'am, Virat Khatne muted you, and he left the meeting.
okay, from where I was new, like, did you all hear? Okay,
Yes.
I'm starting.
No,
Okay,
ma'am, you talked about the. It should be. I think you were in produces
okay,
large amount
so
of.
okay. So a good fuel produces large amount of heat. Okay. If it does not produce large amount of heat, we cannot consider that fuel to be a good fuel. All right. And the another important point is that another important characteristic is that it should not leave any undesirable pollutants. It should not pollute our environment. Okay, if all these characteristics are fulfilled, then a fuel can be considered as a good fuel. Okay, apart from this, there are also other characteristics which we'll look into in the next slides. All right, did you all understand these four properties of a good fuel?
Yes.
Okay, we can move on to the next slide. Now, there are basically three types of combustion. Okay, one is rapid combustion, spontaneous combustion, and explosion. Now, rapid combustion happens rapidly. From the name itself, we can know that the combustion that takes place rapidly is called rapid combustion. Okay. For example, when we strike a matchstick, it burns, it burns immediately, right? So that is rapid combustion. When we light a candle, it burns immediately, rapidly. So that is rapid combustion. Okay. When we burn a gas stove, it also lights immediately. So that is also rapid combustion. So these are examples of rapid combustion. And in case of rapid combustion, a large amount of heat as well as light is produced. You take the example of a candle, of a matchstick, of a gas stove. Okay, they all produce large amount of heat as well as light. And you have to light it without an ignition source, without lighting it, it will not like burn on its own. So there is an external ignition source that is needed for rapid combustion to happen. Okay. Now we move on to the next one, that is spontaneous combustion. Now spontaneous combustion happens all of a sudden without heating or lighting anything. Take the example of a forest fire. Can you all tell me, how does a forest fire take place? Does anyone go burn the forests?
No.
No.
No. So then how it happens?
Ma'am, it happens
Due
due
to the sun
to
heat.
heat.
Yes. When the temperature becomes very high, okay, at that time, the forest starts burning itself. So that kind of a combustion is called spontaneous combustion. Okay, there is no ignition source. What happens is when the temperature rises up, when the temperature becomes very high, then some things catch fire spontaneously without any kind of source. Okay, so that kind of a combustion is called spontaneous combustion. You all can see the picture on the right. That's a metal. What is the name of that metal? Can anyone tell me? This is a metal that is never exposed to air. We cannot keep this metal exposed to air, because as soon as it is exposed to air, it will catch fire. Who will name this metal? Who's going to name this metal?
Potassium.
Okay, potassium. Okay, actually, sodium and potassium both. Okay, sodium and potassium. This is sodium. Sodium is kept in kerosene because it reacts vigorously with moisture. It reacts vigorously with the air, that is the oxygen and carbon dioxide. Okay, so it has to always be kept in a container which has kerosene. Otherwise, without any ignition source, it will react with the oxygen and it will catch fire spontaneously. All right. And the third type of combustion is explosion. You know what is an explosion? It can be with a bomb. Okay.
Firecrackers.
Yeah, firecrackers. So in this case, what is happening? Heat, light, as well as sound is produced. You have to give it a source of heat. Okay, you have to ignite it, then heat, light, as well as sound will be produced. In case of firecrackers, in case of uh, an uh, an atomic bomb or any kind of bomb which explodes. Okay, so these are the three kinds of combustion, that is rapid combustion, spontaneous combustion, and explosion. Are the three types of combustion clear to everyone?
Now I had a
Yes,
question.
yes,
Spontaneous combustion, you gave the example of sodium and potassium. So,
yeah,
like, when the people they take out of the rocks, like the sodium and potassium, when they like extract it, how do they do that? I
yeah.
mean, it is uh, flow off. How do they
See,
extract?
first of all, like when they have to carry out any reaction, it they like if you want to carry out any reaction with it should be done with lots of care. Like you cannot. There are some other things which does not react with them except air and water. Okay, there are some other chemicals that don't react with them. There are some other, like they kept it in kerosene. There are some other things also which does not react, so they have to carefully transfer it there. Okay, and in some cases, like it is actually not exposed to air, because within a very short period of time that will catch fire. So maybe some other chemicals or something else must be done while doing any reaction with while carrying out any chemical reactions with sodium or potassium. All right. Okay, is the slide clear to everyone? I mean, are the types of combustion clear to everyone?
Yes, ma'am.
Okay, so we move on to the next slide. Okay, what is the efficiency of a fuel? How can we know that a fuel is efficient or not? We can know it from the calorific value. Now, what is the calorific value? The calorific value is the value of heat energy that is produced when you burn 1 kg of any fuel. If you burn 1 kg of the fuel, the amount of heat energy that is generated, the amount of heat energy that is produced by burning 1 kg of any kind of fuel, that is the calorific value. Okay? So if a fuel produces large amount of heat energy, then it has a high calorific value. And the fuels having high calorific value is a good fuel. We already studied in the first slide itself that a good fuel is a fuel that produces a large amount of heat. So if we burn 1 kg of fuel and it produces a large amount of heat energy, then that can be considered as a good fuel. Okay. Now take a look at the calorific value. Look at the calorific value and tell me out of these fuels, which is the best fuel on the basis of the calorific value. Which is the best fuel? You can see a table, okay, showing the calorific values of different fuels. So y'all tell me which is the best fuel according to the calorific value. Who's going to tell me?
And hydrogen?
Yes, hydrogen is the best fuel according to the calorific value, because 1 kg of hydrogen is able to produce 1,50,000 kilojoules of heat. Okay, 1 kg of hydrogen is able to produce 1,50,000 kilojoules of heat, which is a very huge number, which is a very huge amount of heat that is produced. All right. So we measure calorific value. What is the unit for it? It is kilojoules per kg. Means for 1 kg, what is the amount of heat that is generated? That is measured in kilojoules. Heat is measured in kilojoules, and you are calculating that 1 kg, how many kilojoules of heat it produces. So that is a calorific value. And hydrogen, according to the calorific value, hydrogen is the best fuel because it produces a huge amount of heat energy. Is that clear? Okay. Now we move on to the next slide. Okay. Now we carried out some experiments. Okay. We learned about the ignition temperature. Now, whatever is the ignition temperature, that is also called the auto ignition temperature. Because now let me tell you what is this. It's the lowest temperature at which a substance catches fire without any ignition source. Okay. It is the lowest temperature at which a substance catches fire without giving any heat source, without igniting it. Like, you can take the example of, maybe you can take the example of petrol. Okay. If you don't heat the petrol, will it burn itself? Tell me. Think and tell me. If you don't heat the petrol, suppose the petrol is kept in a container. Okay. You don't heat it, but will it catch fire?
No,
If you don't heat
ma'am.
it?
No, ma'am.
It won't. Okay. So you are saying that without igniting it, it's not going to catch fire. When the temperature comes to a certain level, the petrol is going to catch fire without even igniting it. And that temperature is called the ignition temperature. Okay. Even if we don't light it, there is a certain temperature which the petrol will reach. Can you all see the ignition temperature of petrol? 246 degrees Celsius. When this temperature is reached, then the petrol will automatically catch fire. Okay. So this temperature is called the ignition temperature or the auto ignition temperature. Okay. This is the temperature. It is the lowest temperature at which something catches fire without any ignition source. Did you all understand what is ignition temperature? You all don't have to light some, you all don't have to heat something, but automatically at a certain temperature, anything can catch fire. So that lowest temperature is known as the ignition temperature. Is that clear? What is ignition temperature or auto ignition temperature?
Yes, ma'am. Yes, ma'am.
Okay. So The substances which have a very low ignition temperature, they will catch fire very easily. You can see phosphorus. Phosphorus catches fire only at 35 degrees Celsius. Okay, so whenever it reaches this temperature, it's going to catch fire. So 35 degrees Celsius is almost room temperature. Okay, so whenever it reaches this temperature, it's going to catch fire. In the same way, diesel, you'll see diesel, kerosene, they are almost only about 10 degrees Celsius difference, the ignition temperature. Okay, and coal, the ignition temperature is very high. It will not catch fire easily. Okay, the ignition temperature of coal is very, very high. That is 454 degrees Celsius. Did you all understand ignition temperature, everyone?
Yes, ma'am.
Okay, so
Yes, ma'am.
we'll move on to the next slide. All right. Okay, we already did the experiments, right? Okay, see, there is something called the flash point or the fire point. Flash point and the fire point. Okay, let me explain. Have you ever seen people like, have you gone and eaten fast food? And you'll have seen when they cook the food, like there is some flame coming on top of the kadhai or whatever pan they are using. A sudden flame coming up. Have you ever seen when you'll eat chow mein or any kind of fast food items? Have you seen that flame suddenly comes on top of the pan or something when they
Yes,
cook?
ma'am.
Yes.
Yes. So let me tell you all what is that. Now that is called the flash point. Okay. It is the lowest temperature at which a substance will vaporize to form a mixture, and that will catch fire. Uh, they are burning, they are cooking food on LPG. Okay, that is liquefied petroleum gas, as we use at our homes. Now, what happens is when they cook food, okay, that vapor, when it rises up, that catches fire, and it will only remain for about 5 seconds, not much. So that temperature is called the flash point. Okay, flash point is when the the fuel, it vaporizes. Okay, it vaporizes, it catches fire immediately, it remains for a very less time. Okay, it will remain for about maybe 5 seconds, and then that flame will go off. So that is called the flash point. That temperature is called the flash point, okay, of that fuel. And what is the fire point? Fire point is when it is the lowest temperature at which something starts burning when you ignite it. All right. Even flash point, you need an external ignition source. In fire point also you need an external ignition source. But in flash point, it will be like a flash. Means the fire will just be produced for a few seconds and then it will go off. But fire point is when the substance or when the fuel it catches fire. Okay, so that when a substance catches fire, that is the fire point. All right, is it clear or should I explain again? It's a bit confusing, but it is different. Both of them are slightly different from each other. Did you follow what is flash point and fire point?
Yes, almost.
Okay, almost. So not completely. See,
I kind of got it.
yeah. See, what do you understand by a flash? Tell me. What is the meaning of a flash? You all have heard about a flashlight. What is a flash? Does a flash means it just flashes and goes off. Okay, so flash point is when the fire just like when something burns suddenly for very less time and then it goes off. Okay, so that is what happens when you ignite something, when you ignite the fuel. Okay, the substance vapor will be produced on top of it, and due to that vapor it will catch fire for about 5 seconds, not more than that, and then it goes off. That is called the flash point. That is the lowest temperature at which a substance catches fire for just a few seconds. That's a flash point. Fire point is the lowest
Nicola ma'am, your voice
temperature.
is not clear. Nicola ma'am, your voice is not clear.
It's clear for me. It's coming pretty clearly.
Yes,
Am
ma'am.
I audible to everyone?
Yes, ma'am. You are.
Yeah.
Yeah. Okay. So fire point is the lowest temperature at which something catches fire. Okay. All right. And for both these cases, ignition source is needed. All right. We'll move on to the next slide. Ma'am, can we go to the next slide? Okay. So by that time, you all can note down the questions for today's class. Okay? Till ma'am joins back, you all can note down the questions for today's class. Write down. Out of petrol, diesel, out of petrol, diesel, CNG, LPG, and kerosene, find out which is a good fuel. Find out which is a good fuel. Which is the best fuel you all can write. Which is the best fuel on the basis of which is the best fuel on the basis of calorific value, on the basis of calorific value, ignition temperature, and the amount of residues that it produces.
And may you please tell again the last option?
Out of petrol, diesel, CNG, LPG, and kerosene, find out which is the best fuel on the basis of calorific value, ignition temperature, and the amount of residues that it produces. And the amount of residues that it produces. Okay, first question, have you all noted down? Okay. Second question, write down. Where is the knowledge of flashpoint, fire point? Where is the knowledge of flashpoint, fire point, and ignition temperature applicable? Sorry. Where is the knowledge of flash point, fire point, and ignition temperature applicable? Discuss. Okay, so these are the two questions. for today. All right, we'll proceed with the presentation. There are just two more slides. Okay. Now, inflammable substances are the substances that catch fire very easily. Okay, the substances that catch fire very easily are called inflammable substances. You all can take the example of petrol, kerosene, diesel, alcohol. Okay, so CNG or LPG. Okay, these are all inflammable substances because they have a very low ignition temperature. They catch fire immediately. So they are called inflammable substances. All right, we can move on to the next slide. All right, now flame. Can you tell me, do all the fuels produce flame? You can tell me.
No, because as I like saw plastics a few days before, it just makes a little ball. It does not
Okay,
catch fire.
so yes, but Nisha, we discussed that plastic is not a fuel. Plastic melts. Okay, it melts, but it does not like burn. It does not. Okay, so plastic is not a fuel. So any other fuels that like do all fuels produce flames? Tell me, do all fuels produce a flame? Think and tell me.
No.
No. Can you give me some examples of fuels that don't produce flames?
Coal.
Okay. Coal does not produce a flame. All right. Yes. Okay. There are some fuels that don't produce flame. You can take the example of a matchstick or wood, they produce flames. Candle produces a flame. Okay. That is LPG, that is the gas stoves that we use at our homes. That also produces a flame. But you take the example of coal. Coal does not produce flame. Okay. There is no light energy that we are getting. We only get heat when you burn coal. Now, what is a flame? Flame is the visible gaseous part of the fire. The fuels which vaporize, okay, that the fuels which convert into vapor, the vapor part of the fuel, it produces flames. If it does not produce vapor, it's not going to produce a flame. For example, coal, the fuel does not produce any kind of vapor. Okay, so therefore there is no flame that is seen. But in the other cases, you can see that a vapor is being produced. Okay, you'll take the example of the candle. The candle wax. Okay, the candle wax, it reacts with oxygen, it produces vapor, and therefore in that region we can see a flame. So the substances which vaporize, they produce flames, and the substances which do not vaporize, they don't produce flames. Okay, we'll move on to the next slide. Okay, we already discussed about the flames, the zones of the candle. Okay, there are basically 3 zones of the candle, that is the outer zone, the middle zone, and the inner zone. The outer zone is the non-luminous zone. Okay, you can see it is slightly bluish in color. It is the outermost zone, and it is the hottest zone. It's the hottest zone. When you compare it with the middle zone is slightly yellowish or orangish in color. Okay, and it is the luminous part. It is the part that provides the light. It is the part that gives most of the light of the candle. Okay, and it is moderately hot. It is not very hot. The outermost zone is the hottest of all. The middle zone is moderately hot. And when you move to the inner zone is actually blackish in color. You all can see the innermost zone. Okay, it is blackish in color and it consists of unburnt vapors. It consists of the unburnt vapors of carbon. Okay, this is the portion that is the least hot. You all might have seen some people like they put in their fingers across it. That's not any kind of magic. It is because that flame is not at all means that part of the flame is not at all hot. Okay, so they are being able to do it. All right, did you understand the three zones or the structure of the flame, the three zones of the candle?
Yes.
Yes, ma'am.
Okay. Okay, so with this we come to an end of this session. Okay, if you have any doubts, you can ask me. Anyone, if you are having any kind of doubts, you can like ask me. Anyone? No doubts? Okay. All right. So did you all understand everything?
Yes, ma'am.
In the next class, we'll be discussing these questions that I've given you all. Okay? All of you all need to attend these questions. In the next class, we'll discuss. All right? Okay. Okay. So we'll meet up in the next class. Okay?
Okay, ma'am.
Thank you, everyone.
Yeah. Thank you.
Thank you, ma'am.
Bye.
Bye, ma'am.